Welcome to Your Math Explained, where we make math simple and clear. My name's Angela, and today we're tackling advanced log equations, the kind that'll test your algebra, logic, and your patience. These aren't the kind of problems that you can crank out in 30 seconds. These are grade 12 challenge problems, the kinds that you might see on a contest. So are you ready to level up? Let's get started. First up, we want to solve the equation 9 log base 5 of x is equal to 25 times log base x of 5. And we want to leave the answer in the form 5 to the power of p over q, where p and q are integers. So notice how we have two log expressions with different bases. So that gives you a hint that change of base is going to be needed here. And you can actually change it to any base you want. Some will be a little bit easier than others. So you can actually change both sides to base 10, or what I'm actually going to do is change both sides to base 5. So on the left-hand side, we already have it in base 5. So let's just leave that as is. So that'll be 9 times log base 5 of x. And then on the right-hand side, we're going to write that in terms of base 5. So that's going to be 25 times log base 5 of 5 divided by log base 5 of x. Multiplying both sides by log base 5 of x is going to give us 9 times log base 5 of x all squared is equal to 25 times log base 5 of 5. But log base 5 of 5 is just equal to 1. And notice how we have a squared on the left-hand side. But that squared applies to the log as well, therefore the power rule does not apply here. So what we're going to do is divide both sides by 9, so then we get on the left-hand side is log base 5 of x all squared is equal to 25 over 9. And now we can go ahead and square root both sides. So let's continue that over here. So then we get log base 5 of x is equal to, and when we take the square root of the right-hand side, we have to make sure that we write both the positive and negative square root. So we get plus or minus 5 over 3. And now we can go ahead and use the definition of a log to solve for x. So we get x is equal to 5 to the power of plus or minus 5 over 3. And lastly, we just need to double check and make sure that both are valid answers. And looking at our original equation, we have log base 5 of x and we have log base x of 5. And both of those require x to be a positive number. And since 5 to the power of both positive and negative 5 over 3 is positive, both of these are valid answers. So we have x is equal to 5 to the power of positive or negative 5 over 3. Our second problem is a question from the 2022 AMC contest. So we're asked to evaluate the value of this complicated looking expression here without the use of a calculator. So the first thing to notice is that everything is in terms of log base 10. But there's no way for us to actually calculate without a calculator what log base 10 of 5 is, or what log base 10 of 2 is. But what you should notice is that everything here is somewhat related to 10. So for example, we have 5, and then we have 20, which is 10 times 2. We have 8, which is 2 to the power of 3. And then we have 0.25, which is 25 over 100. So we have 2, 5, and 2 times 5 is equal to 10. So that tells us we should be writing things down in terms of log 2, log 5, and somehow write a relationship between log 2, log 5, and log 10. So let's go ahead and do that. We know that log 10 is equal to 1. But we can rewrite log 10 as log of 5 times 2. And then using our product rule, we know that we can again rewrite this as log 5 plus log 2. So therefore, we now have this equation that log 5 plus log 2 is equal to 1. So let's say we let log 2 be equal to x. then what's going to happen is log 5 is going to be equal to 1 minus x. And since log 20 is equal to log 2 plus log 10, that means log 20 is equal to x plus 1. And we have our log 8, which is equal to log 2 cubed. Pulling that 3 forward gives us this is equal to 3x. And then lastly, we have our log of 0.25, which is equal to log of 5 over 10 squared, which then is equal to 2 times log of 5 minus log 10. So that means this is equal to 2 times. Since log 5 is 1 minus x and log 10 is 1, we end up with this is equal to negative 2x. And now we have written all these log expressions in terms of x. So let's go ahead and substitute that in. So then our expression becomes 1 minus x cubed plus x plus 1 cubed plus 3x times negative 2x. And we're going to need to expand the cubes. So that's going to be 1 minus 3x plus 3x squared minus x cubed. So that's the first one. Plus x cubed plus 3x squared plus 3x plus 1. That's the second one. And then the last term is going to be minus 6x squared. And now we can go ahead and combine like terms. So we can see that the cube term will cancel out. And then we have the x squared term will also cancel out because we have plus 6x squared, and then we have the minus 6x squared. And then again, the x term will also cancel out because we have minus 3x plus 3x. So finally, we're left with 1 plus 1, so therefore this is equal to 2. And now we have come to the final question of this video, and this one is from the 2018 Euclid contest. I hope you have a large piece of paper ready because this one is going to take up some space. So looking at this equation here, the first thing we notice is that we have two log expressions with different bases, and that is always a hint for us to apply the change of base rule. And this time, I'm going to actually rewrite everything in terms of base 10. So for the left-hand side, that's going to give us log of 48 times the cubic root of 3 over log of 2x. And then the right-hand side is going to be log of 162 times the cubic root of 2 divided by log of 3x. Next, we're just going to clean up the numbers a little bit. So 48 times the cubic root of 3 can be written in terms of 2's and 3's. So we're going to get log of 2 to the power of 4 times 3 to the power of 4 over 3 over log of 2x. And doing the same thing on the right-hand side is going to give us log of 3 to the power of 4 times 2 to the power of 4 over 3 over log of 3x. Next, we're going to use the power and product rule to split up the logs. So then we get 4 times log 2 plus 4 over 3 times log 3 over log 2 plus log x. And then the right-hand side is going to be 4 times log 3 plus 4 over 3 times log 2 over log 3 plus log x. And next, we're going to need to cross multiply. And yes, I know it's going to look a little bit messy, but things will actually start canceling out. So the left-hand side is going to be 4 log 2 plus 4 over 3 log 3 times log 3 plus log x. And then the right-hand side is going to be 4 log 3 plus 4 over 3 log 2 times log 2 plus log x. And now you're going to expand that and then move all the terms with x to one side. So let's say we move all the terms with x to the right-hand side and factor out log x. Where we're going to end up with is log x times 4 log 3 plus 4 over 3 log 2 minus 4 log 2 minus 4 over 3 log 3. And then on the left-hand side, we can see that we actually have the term 4 log 3 log 2 and 4 log 2 log 3. So they actually end up canceling out. So that means on the left-hand side, we're only going to be left with 4 over 3 times log 3 squared minus log 2 squared. So now let's go ahead and clean up the right-hand side a little bit. So we can combine the log 2's together and then combine the log 3's together. So we get this is equal to log x times 8 over 3 log 3 minus 8 over 3 log 2. And then the left-hand side stays the same, so I'm just going to write quotes for that. And notice how on the right-hand side, we can actually factor out 8 over 3. So if we did that and then multiplied both sides by 3 over 4, what's going to happen is on the left-hand side, we will have just log 3 squared minus log 2 squared. And then on the right-hand side, we're going to have a 2 in the front times log x and then times log 3 minus log 2. And now finally, we can go ahead and isolate log x. So we get log x is equal to log 3 squared minus log 2 squared over 2 times log 3 minus log 2. But notice how the numerator is just a difference of squares. It looks like a squared minus b squared, and we know that we can factor that into a plus b times a minus b. And if we did that, we would have log 3 minus log 2 times log 3 plus log 2. But then the log 3 minus log 2 is going to cancel out with this part of the denominator. So therefore, we get log x is equal to log 3 plus log 2 divided by 2. And now we can finally go ahead and combine the logs. So log 3 plus log 2 is going to be log of 3 times 2, which is log 6. So finally, we end up with log x is equal to 1/2 log 6, which is the same as log 6 to the power of 1/2, which is square root 6. And finally, now we're at a point where we can say that we have log base 10 on both sides, and since they're equal to each other, that tells us that the argument must be equal to each other. So we end up with x is equal to the square root of 6. So I know that I skipped over some of the algebraic steps here because I was running out of room. So feel free to actually write all the steps down on your own piece of paper. So this question was actually quite tough. And if you managed to follow all the steps, great job. This was no small feat. So let's do a quick recap of everything that we covered. Being able to recognize symmetry or structure is huge when it comes to challenging problems, because a lot of the times the expressions can look complicated, but they aren't random. So for example, like the AMC problem, spotting patterns in there can actually unlock clever substitutions. And don't worry if you didn't notice that at first, because that comes with practice. And one thing that pops up over and over again is the hidden squares, as in when the log expressions are squared as a whole, we can't pull the exponent in the front, because the power rule only works on the argument, not the entire expression. And finally, change of base is your best friend, especially when bases don't match. So whenever you see a problem where they have different bases, that is a hint that you want to convert everything to a common base and then simplify. And now, it is your turn to give this a try. Can you find a solution to this contest problem here? Make sure to leave your answer in the comments below and let us know if you'd like to see more challenging contest problems in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.